Hello Math 3 and welcome to your first video of Module 3. So just so everyone knows, the notes from this video do not align with the notes that I handed out in class. I decided to kind of ditch the task and do something else. So if you want to pause the video right now and go print the notes, feel free to go do that. Or you can just, take notes on a notebook paper. But just keep in mind that these will not match the notes from the 3.1 task that you picked up in school. I do apologize for that, but I just figured that this was a better way to teach it. All right, so basically the front page of these notes, we have all of these different kinds of function tables. And what we need to do is we need to figure out what kind of function it is, how do we know it's that kind of function, and the standard form of the function. All right, so let's go ahead and look for the first one. Now, I know you guys learned this back in Math 2, but let's kind of just remind ourselves. So we have linear functions, quadratic functions, and exponential functions. And I'm also going to introduce a new one. So let's kind of talk about the order in which we check for these. So the first thing we're always going to do is check for a first common difference. If it has a first common difference, that tells you that it is linear. If it doesn't have a first common difference, the next thing you should do is check for a common ratio. If it doesn't have if it has a common ratio, it's going to be exponential. All right. Then the third thing, if it doesn't have a common ratio, you're going to check to see if it has a second common difference. All right. If it has a second common difference, it's quadratic. And now I'm going to throw in a new kind. If it doesn't have a second common difference, you're going to check to see if it has a third common difference. All right. So for the third common difference, that's called cubic. All right. So this is kind of this is how we're going to do all of these problems. All right. We check for first common difference. If not, we do common ratio. If not, we do a second common difference. If not, we do a third common difference. All right. So that's kind of the flow of this. So let's go ahead and try the first one. So first, let's check for our common difference. All right. So to find a common difference, you always do the bottom minus the top. So we do 5 minus 3. Well, we added 2 there. 7 minus 5. We went up 2. 9 minus 7. We went up 2. And 11 minus 2. We went up 2. So this one has a first common difference, right? Because we added 2 each time. So our type of function is going to be linear. How do you know? We had a first common difference. All right. Now it asks for the standard form of the function. All right. So standard form of a linear function is y equals mx plus b. I'm sure you are familiar with that by now, hopefully. All right. Let's go ahead and try the next one. So this first one was a linear function. So the next one. All right, let's go ahead and check for a first common difference here. So we'll do 8 minus 3, so we went up 5. 15 minus 8, we went up 7. 24 minus 15, we went up 9. And 35 minus 24, we went up 11. All right, so we don't have a first common difference here. Do you see how that changes? So let's go ahead. I'm going to do it in a different color. I'm not going to erase all my work because I might need it. But let's see if we have a common ratio, right? So the ratio from here to here would be 8 divided by 3. The ratio from here to here is 15 divided by 8, which doesn't reduce. We get 24 divided by 3. I'm sorry, 24 divided by 15, which would give you 8/5. All right. So if you notice, these ratios are not common here, right? If you plug these into your calculator, these fractions are not equivalent. So we also do not have a common ratio, so we know it's not exponential. So now let's go ahead, see if we have a second common difference, right? So we checked first common difference, didn't work. Checked common ratio, didn't work. So now we have to check our second common difference. So 5 to 7 is plus 2. 7 to 9, plus 2. 9 to 11, plus 2. All right. So we have a common difference there, right? What kind of a common difference? It's a second common difference. So we have a quadratic. And how do we know? We have a second common difference. Or how about a common second difference? I feel like that makes more sense. And the standard form of a quadratic is y equals ax squared plus bx plus c, right? A quadratic looks like this or looks like that, remember? And I guess I could show you what a linear function looks like. Linear is going to be a line. It's going to go up and down, just like that. All right, so let's go ahead and try the next one. So we'll go ahead, see if we have a first common difference. We're going to do 11 minus 3. That's going to be plus 8. 26 minus 11. It's going to be plus 15. 50 minus 26 is going to be plus 24. And 85 minus 50 is going to be plus 35. So clearly we do not have a common first difference here. So let's go ahead and check our ratio. All right. So our ratio would be 11 over 3, 26 over 11, 50 over 26, which we can reduce to 25 over 13. But notice, right, you can't reduce any of these fractions. So none of these ratios are equivalent, right? If you plug these fractions in, you can't reduce them. They're not equivalent. We do not have a common ratio. So it is not exponential. So let's go ahead and try for a second common difference. 15 minus 8 gives us 7. 24 minus 15 gives us 9. And 35 minus 24 gives us 11. So we do not have a second common difference. So far we've crossed off first common difference, common ratio, second common difference. Now we've got our last option here, which is third common difference. Do we have it? So let's try it. 9 minus 7 gives us a 2. 11 minus 9 gives us a 2. So this one, look, we do have a third common difference, right? So that's called cubic. All right, and how do you know we have a third common difference? And the standard form of a cubic function is y equals ax cubed plus bx squared plus cx plus d. All right. All right. Next thing, we will try our last one here. Let me erase my x's. All right, so we'll try this guy. Again, we'll start off seeing if there's a first common difference. So we get 9 minus 3, which gives us 6. 27 minus 9, which gives us 18. 81 minus 27, which gives us, which gives us 54. And 243 minus 81, which gives us 162. So clearly no common difference here. So let's check our second one, which is a common ratio. All right, so we're going to do 9 divided by 3. That gives us 3, right? 27 divided by 9 gives us 3. 81 divided by 27 gives us 3. 343 divided by 3. 343 divided by 81 gives us 3. So clearly we have a common ratio, right? So a common ratio means exponential. All right, and how do you know it's exponential? We have a common ratio. You can tell it's early in the morning. I'm getting my notification to go to work. All right, in standard form of the function. So the standard form of an exponential function is y equals a to the power of x. All right. Oh, and you know, I didn't give you the shapes of a cubic or an exponential. So a cubic graph is going to look something like this, which is kind of new. Or it might look like that. Fun looking graph. And then an exponential is going to look like this. Or it could look like, there's a couple different ways it could look, but it's going to have that same general shape. All right. So now let's go ahead. We're going to try some of these together. I do want you guys to, you're going to have to do them with me. So, you know, make sure you're kind of paying attention doing them with me because I'm going to embed questions in the video. All right. So let's go ahead for number 1. Does this guy have a first common difference? All right. So we look, we get 8 minus 4, we get plus 4. 16 minus 8, we get plus 8. 32 minus 16, we get plus 16. Not a first common difference. So let's go ahead and check for a common ratio, right? That's our next thing to check off. We get 8 over 4, I got 2. 16 over 8, 2. 32 over 16, 2. 64 over 32, 2. So we got a common ratio, which means exponential. All right. So for number 2, let's go ahead and see if we have a common difference. So 7 minus negative 2. So make sure when you plug this into your calculator, negative 7 minus negative 2. You have to plug it in like that, okay? So when you plug that in, you should get a minus 5. It went down by 5. So we do negative 12 minus negative 7 minus 5. Negative 17 minus negative 12 minus 5. Negative 22 minus negative 17 minus 5. So I want you to go look up here. This is a first common difference, right? So what do we have? We have a first common difference. It's going to be a quadratic, right? Or, geez, not quadratic. Linear. I was just messing with you. All right. Let's go ahead and check box number 3. All right. We're going to go ahead first check for a first common difference. So 4 minus 7 gives us a negative 3. 3 minus 4 gives us a negative 2, or negative 1. 4 minus 3 gives us a positive 1. 7 minus 4 gives us a positive 3. All right. So obviously not a first common difference. We can check for a common ratio. 4 over 7. 3 over 4. 4 over 3. Clearly, these are not equivalent fractions. They don't reduce to the same number. There's no common ratio. So now let's check for a common second difference. We do minus 1 minus negative 3. That's going to give us a positive 2. 1 minus negative 1. That's also going to give us a positive 2. 3 minus 1. Positive 2. So here we have a common second difference. What does that mean? So a common second difference should mean quadratic. All right, number 4. We have to figure out what this is. Let's go ahead. Check our common first difference. We do negative 1 minus negative 8. We get 7. 0 minus negative 1. Now, it is very important, though, guys, that you're doing this number minus this number. Okay, you do the bottom minus the top. So 0 minus negative 1, we get a positive 1. 1 minus 0, we get a positive 1. 8 minus 1, we get 7. So no common first difference there. Let's check our ratio. Negative 1 divided by negative 8. It's going to give us 1/8. We get 0 divided by negative 1. That just gives us 0. We get 1 divided by 0, which is no good. That's actually very bad in math. We can't divide by 0. So this actually is going to be no common ratio. All right. So now let's go ahead and check our common second difference. All right. So we're going to do 1 minus 7. Gives us a negative 6. 1 minus 1 gives us 0. 7 minus 1 gives us 6. No common second difference either. It's our last hope here. We got to check for a third common difference. 0 minus negative 6. That is going to give us a positive 6. 6 minus 0 also gives us a positive 6. So we have a common third difference. What does a common third difference mean? What kind of a function is this? So it's going to be cubic. All right. So let's go ahead and try number 5. I want you guys to actually try number 5 on your own. So try it. All right. So I look at number 5. I checked for a first common difference. I do -7 minus -9. I get +1, or +2. -1 minus -7, I get +6. And then I get 9 minus -1, I get +10. And then 23 minus 9, I get +14. All right, so no common first difference there. We can check for a common ratio. You should have found that there was no common ratio, so we'll check for a common second difference. I got +4, +4, +4. So this one is quadratic. All right, and we got our last one. Again, try it on your own. All right, so we get our common first difference. I got +5, +35, +95, +185. All right, so no common first difference there. I'm looking at it, definitely no common ratio. You could do it, right? 11 over 6, 46 over 11, 141 over 46. None of these numbers are equivalent. So let's check for a common second difference. I get +30, +60, +90. No common second difference. All right, our last hope here, common third difference. Got +30, +30. All right, so you should have gotten a cubic for this.